Hello, my name is Miss Fine and I'm here to tell you a little bit about A-level physics and why it might be a subject you're interested in studying. You can see on this slide, if you're interested in the limits of space, the beginnings of time and everything in between, it is a subject that you will find interesting. A-level physics sets the scene for one of the most fundamentals of all sciences. Physics studies energy and forces, the two things that hold the universe together, and basically explain the creation of the universe, the existence of the universe, and everything in it. So studying this subject, you're going to be looking at massive objects like stars, galaxies, solar systems, down to the tiniest of particles, such as the quarks and the leptons and the baryons that make up the structure of the atom. A-level physics is the study of everything around you and how it works. And we've still got loads of unanswered questions and opportunities. You've got things like, what is gravity? We know it exists, but we still can't explain it. So why should you study physics? There is a shortage of STEM-based jobs out there, or people who are trained to carry them out. And physics is one of those fundamental subjects that underpins all of the STEM roles. So having physics at A-level and possibly pursuing it further at university will open up massive employment opportunities for you. Even if you don't go on to be a physicist, learning to think like one will equip you with problem-solving skills in particular. It's going to show immense mathematical capabilities, the capacity to logically sequence and to power your way through very challenging situations. And ultimately, physics is one of the Russell Group University's facilitating subjects. This means it's an A-level that is considered to be hugely academic and will open the doors for wide opportunities of degrees like law and finance, economics, architecture, engineering. So physicists are the people who look for hidden laws and as a way to explain everything about matter and the world around them. And because of this, these laws can be used to develop new materials, new technologies. It can solve problems and issues so that the future is going to be better. So if we're considering those skills you get from studying physics at A-level, you're going to be learned to be objective, analytical, methodical. You're going to process information and therefore solve problems. It is also going to be building on your mathematical capabilities. And if physics A-levels is where you stop, it's still going to have given you this understanding of a really challenging science, and therefore is going to help you access and understand current events. You know, things like the issue we had earlier in the year about 5G networks and whether or not there were going to be problems associated with it. The world of physics has got to be at the forefront of renewable energy sources and even dealing with nuclear power. Artificial intelligence and robotics are obviously at the cutting edge of development now. And obviously we're still looking at the prospect of space travel and exploration. We've got the possibility of a journey to Mars in the next 5 to 10 years. So the world of physics is immense in terms of its careers. And if you're interested in looking a bit further at where physics-based careers can tell you, the Institute of Physics or the IOP is somewhere where you could have a look. And if you look at the slide, we've got places like cancer treatment, climate change, gaming, robotics, artificial intelligence, all of those requiring a physics-based qualification. And, people look at physicists as being the logical people, the people who can link concepts together. And that's why you often find physicists in careers such as finance and law. So if you do choose A-level physics, what are you going to learn? Now, most importantly, the first year builds on your GCSE understanding. And so it's going to be touching on energy and forces and electricity. You're going to be looking at atomic structure again and subatomic particles, and you're going to be introduced into the world of, quarks and leptons and baryons. It's going to build on your understanding of mechanics, waves and electricity. But most importantly, it's also going to build on those practical skills. There's going to be 6 core practicals that you undertake during your first year at physics, and they're going to build on skills like data analysis, precise and accurate data, dealing with errors and that sort of thing. When it comes to your second year at A-level, you're going to build on those topics but study them in much further depth. You're going to do further mechanics and thermal physics, nuclear physics, but we also have a physics option, and we have quite a wide range to choose from, like astrophysics, medical physics, engineering, electronics. And we don't decide on that option until you as the students in front of us have actually considered them for yourselves. And also in that second year, that's when you really cement your practical skills and make sure you have the practical knowledge and know-how to move into further degree level science study. Here at Meaden, we study AQA, the AQA specification, and I know you do at Garibaldi as well. And so by doing the AQA A-level physics specification, it means that we build on those really strong foundations set at GCSE. The specification is written to follow on seamlessly from your GCSE. Now, there is an AS level, which is basically a 1-year course, but the standard A level is a linear 2-year course with exams just at the end. So let's have a look at what those exams are going to entail. You have 3 exam papers at the end of the linear course. Paper 1, which mainly covers your year 1 AS content with a little bit of periodic motion and harmonics. Then paper 2 looks at your thermal physics, your further mechanics, your nuclear physics. And in both of those papers, you're going to be tested on not just your theoretical, but your practical knowledge as well. Paper 3 is a synoptic paper. It has a compulsory section that looks at all 12 of your core practicals and your data analysis and analytical skills. And then the second half of the paper is the chosen option. If you're wondering about your entry requirements to take this at A-level, like all of our A-level subjects, you are required to have English language at level 5. Now, to do A-level physics, we really need you to have GCSE maths at level 6, otherwise you're not going to cope with the mathematical content. You also need to have GCSE physics at level 6, or your GCSE science at level 6-5, but with a secure level 6 in the physics papers. And at this point, we really do strongly advise, if you're going to be taking A-level physics, it would be really, really encouraged to do A-level maths as well, as the physical maths aspect is much higher than the GCSE level. So I hope you've actually understood a little bit more about the A-level physics. And so what are your next steps? If you have any further questions, it's really important to speak to your science teachers. But if you'd like to learn a little bit more about how the A-level physics is taught at Meaden, please feel free to email me at tvine@meadenschool.co.uk. And so finally, obviously, when choosing an A-level, it's really important to have a look at all of the options out there. If you have a particular career in mind, please make sure you've done your research and made sure you know whether or not A-level physics is an essential requirement of that. So I hope you've actually understood a little bit more about the A-level. Goodbye for now.